Hello everyone and welcome to our presentation on chip shortages and the current supply chain issues the world is facing. Let's get into it, starting with Boaz.
It's very important for the consumer to be able to get the various goods that they can afford, which is a very key point. The semiconductor shortage has made it unable for the average consumer to get various technological devices such as phones, computers, cars, and the like at affordable prices. This shortage has caused many individuals great distress and has caused many companies to face many supply chain related issues. Intel is a great example of this. Their production, in spite of the relatively large number of manufacturing sites displayed here on the right hand side, they are struggling with keeping up with the demand of the consumer and even corporations. Now, there are many factors to this. A key factor is that we're just in the age of COVID, where people for a very long time were unable to leave their homes for prolonged periods of time. So that caused demand for technology to skyrocket, and supply just couldn't keep up. So, why is Intel specifically a good example of this? Well, it's because they've commented on the issue numerous times. Now, Chief Executive Pat Gelsinger is optimistic, and we can see why they're optimistic about their supply chain issues. Over to the left, we can see numbers relating to Intel as a company. They have a large workforce right here. A large number of transistors are being manufactured. And we also have 16,000 companies supporting Intel. So that's a lot of money backing Intel and their mission to get these various goods to the people. So they are optimistic about their future in semiconductor production. You can see from Pat Gelsinger's quote here that he believes that the semiconductor shortage will ease through 2022 and fade in 2023. So, if this prediction is right, then this shortage probably lasts for roughly almost 1 to 2 years, which is great news, assuming Pat Gelsinger's prediction is accurate.
Chip production is very important, and many of the companies working in this sector find themselves specializing in different stages of the chip production process, starting with ISAs, or Instruction Set Architecture. This is where the most basic actions of the chip are designed, like accessing memory or performing binary calculations. Anyone can design an ISA, but they become very strong whenever they are industry standards like ARM or x86. An example of one of these would be the recent M1 chips Apple has designed. After ISAs comes the chip design process. In the chip design stage, many companies you are familiar with operate, such as Google, Amazon, etc., like that. They design diagrams called masks, essentially a blueprint of the chip that shows fabricators where they want the memory arranged on the silicone and various other things. The picture here is a diagram of a mask. Some companies manufacture their own chips for unique and cutting-edge research and projects, but the vast majority send blueprints to specialized contract manufacturers called fabs, like industry leader TSMC. Machine for Extreme C has bought 13 of them. EUV machines have a high operation cost and require lots of skilled operators to work and troubleshoot in different scenarios. It's processes and steps similar to these that make chip production an expensive market to research, develop, and compete in. The fabrication process is just so expensive and competitive that many other companies cannot afford to compete. ASML, besides being a monopoly on lithography EUV machines, has also created a bottleneck as fabs need this machine to create high-end chips. It's not an entirely terrible thing though, as because fabs carry out orders from many companies at a time, it will allow them to use economies of scale and use older hardware to create less advanced chips with older machines, because not every mask design is for a high-end performing chip. After the fabrication process is complete, the chip moves on to assembly and testing, where the silicone wafer is cut up and put into a protective housing where wires and connections are attached. After this, it is tested and sold back to chip designers for final testing, where they will become assembled into electronic devices.
Inventory. There was a shortage of chip inventory due to a few different factors. One being the increased demand for semiconductor chips during the pandemic, along with some bad decisions being made by the auto industry. During the pandemic, there was an increase in demand for electronic devices. People were just spending more time indoors. Electronics such as gaming consoles, PCs, and phones were also useful for passing time while people stayed in their homes. Something else that happened was people started working from home a lot more, meaning laptops or other devices that use chips may be necessary in order for people to work remotely from home. During the pandemic and the lockdown, one way to stay connected with others was also through devices that connected to the internet, which also make use of semiconductor chips. And e-commerce also had a huge surge in popularity, and people just had more time to shop online, which also meant more chip-containing products were most likely being bought. Another big factor to the shortage of chip inventory is that the automotive industry predicted a lower demand for vehicles due to the pandemic, so they lowered the amount of semiconductor chips that they ordered from chip manufacturers. This was an issue because the automotive industry makes use of the just-in-time inventory method, which is where the supplies that are used to make a product are delivered as needed, meaning that the automakers had little to no chip inventory that could be used for production. Along with this issue, the prediction that the demand for automobiles would decrease was also inaccurate. Instead, it had actually increased much faster than expected. And by that time, chip makers had already made deals with other industries, and with little to no inventory, this resulted in a high demand but low supply of chips for the auto industry. Another thing is that modern cars are a lot more reliant on electronics that include chips. And here is a diagram of what percentage of electronics in cars include semiconductor chips.
So location has had quite the impact on the chip shortage. As we know, in data storage, it's best practice to have 3 copies of your data and store at least one of those in a different building, because if you keep them in the same place, well, what if there's a fire or a flood? And so different locations have different circumstances that could happen to them, like natural disasters, fires, power outages. Sicknesses could spread through an area or in a factory, or there's government restrictions. So in Japan, Renaissance, they make a third of the chips used in cars, and they had to shut down their plant because of a fire caused by a power surge. It took them a few months to get back up to speed. The winter storm in Texas had quite the impact on the shortage as well. NXP Semiconductors is a major provider of automotive and phone chips. They had their power shut off due to low power capacity and to reduce strain on the electric grid. In Taiwan, there was a drought last year, and now Taiwan is known as one of the most rainiest places in the world. But but it recently had a rare drought, and TSMC was ordered by the government to reduce their water consumption by 15%. So there is some good news here. TSMC is going to spend $100 billion over the next 3 years. $12 billion will be spent on a semiconductor factory in Arizona. TSMC said the factory will create more than 1,600 high-tech jobs, and they are expected to begin production in 2024. They are also going to build the first 2-nanometer capable fab in Taiwan. The Samsung foundry, they are going to spend $17 billion on a new fab in the USA by late 2023. It's going to create 1,800 jobs, have an economic output of around $8.6 billion, and salaries for permanent workers to total $7.3 billion in the first 20 years of its operation. Intel is also spending $20 billion to build 2 new chip plants in Arizona. And they also announced they are now going to act as a foundry, which means they are going to manufacture chips for other companies.
The only certainty for supply chains in the future is more disruptions. While several stable years can lull supply chain managers into complacency, the truth is that supply chain disruptions, shortages, shipping delays, and price increases can come at any time. Manufacturers should be proactive in protecting their supply chain, paying attention to where their chips come from, and the risks that might be associated with their sourcing. Knowing that a shortage of chips could shut down production for a manufacturer, more thought should be given to having a back inventory to bridge any delays. The past months have shown the weaknesses of having a just-in-time supply chain. Whether 2020 was the death of lean supply chain management is debatable, but going forward, smart supply chain professionals will be better prepared for the next crisis to come along. The cost of buying more computer chips as inventory and housing that inventory should be weighed against the risk of having a factory shut down because of a lack of supply. Having a diverse range of computer chip suppliers and multiple sourcing options will also protect companies from supply chain disruptions.
How some companies have avoided recent supply chain issues. So huge companies like Amazon have amassed such a wealth that they're able to charter private means of transportation, meaning cargo planes and ships that they own specifically. This has allowed the company to control where and how their goods are shipped, which means Amazon goods are able to avoid the most congested shipment ports. Down below is a picture of an Amazon chartered ship with Amazon-created cargo containers at the port of Houston. This allowed them to avoid huge ports that are rather congested, meaning their goods would be able to arrive on time. Amazon has also increased its private shipping methods over the years, from just below 47% in 2019 to around 72% in the beginning of 2021, and it's also projected that this will eventually increase to 100%, where Amazon is just privately charting their own stuff. And below, Amazon is even making their own cargo containers, which I touched on before. If the supply chain issues and item shortages like chips continues, we will see more major companies with the financial ability privatizing transportation. We may also see the rise of new companies looking to become the solution to the supply chain congestion. And here are our resources.